Think about when you wake up in the morning. You turn on the lights, push down the toaster, and flip on the television. All of these heavy appliances draw power seamlessly from a single wall outlet. To get that electricity, you don't build a personal power plant in your backyard, complete with smokestacks, security guards, and cooling fans, just to turn on a single light bulb. You simply plug into the grid. Yet, in the digital world, building a backyard power plant is exactly how computing worked. Early tech companies had to build massive physical rooms, filling them with heavy tape drives and servers just to process basic data. Maintaining these server rooms was an immense financial and physical burden. Companies had to buy all of this expensive hardware upfront and hire dedicated staff to constantly repair complex, exposed circuit boards when things broke down. Cloud computing replaces that entire burden. It is the digital equivalent of plugging your home into the global electricity grid. This shift moves the center of gravity away from owning and maintaining physical hardware and toward renting computing power on demand from companies that have already built the infrastructure. The name cloud is a metaphor for a massive physical reality. At its core, the cloud consists of highly secure, massive industrial data centers owned by major tech corporations. These are sprawling physical buildings equipped with enormous cooling infrastructure and their own power generation. Inside those buildings are thousands of powerful computers, networked together in endless racks, with heavy cables routing data back and forth. Watch how the cloud handles viral growth, known as scalability. A single digital room, representing a server, instantly duplicates as user traffic surges. This prevents applications from crashing. Once the spike ends, the extra rented rooms are immediately returned to the provider. This ability to scale up and down protects businesses from catastrophic technical failures during viral moments, while also saving them from wasting money on empty servers during slow periods. Because you only pay for what you use, the financial model is exactly like your monthly electric bill. You are only charged for your actual consumption. You get the perk of zero maintenance. Providers handle physical repairs, hire security guards, and install software updates. This diagram shows the cloud computing menu. The bottom tier, IaaS, rents raw computing and storage. The middle tier, PaaS, provides tools for developers to build apps. The top tier, SaaS, represents ready-to-use applications for consumers, like email or streaming. Regardless of which layer you interact with, the advantage remains the same. You are completely offloading the burden of physical infrastructure to a centralized provider. You are already interacting with this massive infrastructure every single day through the phone in your pocket and the laptop on your desk. Notice how users in Tokyo and New York access the exact same file from a centralized data center. Your local device is just a glass pane. The actual heavy computing happens thousands of miles away, completely out of sight. The only requirement to harness this global computing power is a basic internet connection. Uploading to the cloud literally means taking your personal data and parking it inside someone else's secure supercomputer. The cloud functions as a global utility. It takes supercomputing power that once required entire buildings and millions of dollars and makes it accessible for anyone, anywhere.